piecewise linear functions. A function is a piecewise function when it models data that has a different pattern on different pieces of its domain. So a piecewise function may have more than one, or will have more than one formula, so to speak, related with it. If all the pieces of the function are linear, then we call it a piecewise linear function. Here's an example of a piecewise linear function. The first piece of the function is x plus 3. And we use this equation, this part of the equation, when our x values are bigger than -4 and less than 7. The second part of the function is 2x minus 5, and we use this part of the function if we have x values between 7 and 10. The last part of our function is 4. We use this part of our function if our x value is greater than or equal to 10. So first, let's find some function values. Then we'll look at how to graph a piecewise function. So finding the function values involves first seeing what your x value is and seeing which of your domains that x value falls into. If x is -3, it's going to fall into the first domain between -4 and +7. So that means I need to use this part of my function to find the value of f of -3. So I'm going to use f of x equals x plus 3. So when I plug the -3 in, I get -3 plus 3 will give me 0. So f of -3 is 0. Now let me look at this function value. Here my x is 0. 0 falls in the same domain, so I'm going to use that same function here. So I'll still use the x plus 3. When I plug the x value of 0 in, I have 0 plus 3, which gives me a y value of 0. So f of, I'm sorry, not 0, 3. F of 0 is 3. Now if I want to use an x value of 8, 8 falls within this domain. So to find f of 8, I have to use this part of my function. So here I'm using f of x equals 2x minus 5. So f of 8 would be 2 times 8 minus 5, which is 16 minus 5, which is 11. My next one, I have f of 12. If my x value is 12, it falls in this part of my domain. So that means the function I use here is just f of x equals 4. So f of 12 would be 4. Now let's look at how to graph one. Here I have a different function. Here I'm using x plus 3 for x values bigger than or equal to -4 and less than 0. And I'm using the opposite of x for x values between 0 and 4. So basically, I'm going to graph two graphs on the same grid. So I'm going to take the first part of my function, f of x equals x plus 3. And I want to graph that for x values going from a -4 up to a 0. Now, I know that this is going to be a straight line. 2 points is really all I have to graph this line. I could get a few more points if I want to. But 2 of the points you must use are the end values of your domain. So I have to use the -4 and I have to use the 0. So when I plug in -4 for x, I would have -4 plus 1. I'm sorry, -4 plus 3 will give me -1. When I plug in -3 for x, I would have -3 plus 3, which is 0. When I plug in -1 for x, -1 plus 3 is 2, so I would get a y value of 2. And when I plug in 0, I get 0 plus 3, so I have a y value of 3. So I want to mark these points on my graph. -4, -1 is right here. -3, 0 is here. -1, -2, 1. -1, 2. I said it backwards. I'm sorry. -1, +2 is here. And 0, 3 is here. Now I need to be a little careful. I want to include the end value at -4 because I have the equal mark with the -4 part of the inequality. But I don't want to include this end value, so I want to make it an open circle. So here is the first part of my piecewise function. Now, I want to go to the second part of my piecewise function. So that is the f of x equals the opposite of x. And I want to do the same thing here. I want to use the beginning endpoint and the ending endpoint. This time let me just find one more value in the middle. So I've got to use the x equals 0 and I've got to use the x equal 4. In this case, both of these end values will be included because I have the equal part at both sides of my inequality. So if x is 0, y will be the opposite of 0, which would be still 0. If x is 2, y would be the opposite of 2, which would be -2. And if x is 4, y would be the opposite of 4, which is -4. So this graph is going to go from here, 0, 0, to 2, -2, to 4, -4. And then I draw my line. So I have two parts of my graph. Sometimes the two parts of the graph will connect. If they connect, we would say that it's a continuous graph. In this case, they do not connect. So it is not a continuous graph.